ORB networks being deployed at scale by cyber espionage actors, this isn't a phenomenon. This is really a standard practice that has been adopted by a large number of Chinese-nexus APT actors. We're no longer talking about a custom botnet being utilized by actors like APT31 that has been talked about previously in like the backdoor malware. We're talking about, since 2016, the rise of a private sector industry that has really been created to facilitate evasion at scale.
Welcome to another episode of Mandiant's Defender's Advantage podcast. I'm your host, Luke McNamara. Joining me today is Michael Raggi, Principal Analyst at Mandiant Intel. Michael, great to have you here.
Hey, Luke. Thanks for having me on.
So today we're going to talk about something that I think has been an interesting theme in China-nexus cyber espionage activity throughout last year, certainly actually before that. And if you had to ask me to pick what were some of the big notable trends from what we were seeing from that adversary last year, of course, I'd have to talk about edge infrastructure, the targeting of that, particularly with 0 days, the continuation of that trend that we've been seeing for some time. I think UNC 4841 is a great example of that larger trend. I think another trend you'd have to mention is certainly Volt Typhoon and the concern around the targeting of OT networks and potential sabotage. And then something that we've not talked about as much, but we're going to get into today, that I think is also, exemplified some of the analysis we were doing around China-related cyber espionage activity, is the ORB activity. So that's what we're discussing today. To kick us off, Michael, maybe just describe what are the ORBs and how are we seeing them be employed?
Absolutely. So I totally agree. ORB networks are an interesting and probably one of the biggest shifts in the Chinese landscape that we've seen as analysts probably in 8 years or so. ORB networks, as they are defined, are operational relay box networks. So it's helpful to think of ORB networks as these mesh networks, VPN-like networks utilized by multiple cyber espionage adversaries to obfuscate their traffic as they're conducting cyber espionage campaigns. So largely, these are networks consisting of leased VPS devices or compromised routers or IoT devices that form together in a pseudo botnet to be utilized by multiple APT actors. But there's a couple of things that are really important to note about ORB networks that are unique to China-nexus activity that aren't consistent with our definition of things like botnets. So our industry is really familiar with botnets and their use in cybercrime, things like bulletproof hosting. ORB networks are a little different. These are networks that are created by private sector entities in China. These sector entities create the botnets by making their own malware to compromise these routers. They recruit the routers into their network, and then they build tunnelers through the network that customers, like certain APT actors, can purchase use of that ORB network and use it like we would use a VPN. So it's a really interesting story about a rise of a private industry in China enabling cyber espionage activity at scale, rather than a story about one threat actor or one topical issue. This is really an enablement process that has really been ongoing since 2016 all the way through to 2024.
And we're going to talk a little bit about that, of how I think it's exemplative of some of the trends and how, this is not a new thing, but certainly the increasing capability, dare I say, sophistication, the changes in techniques that we're seeing from China-nexus groups, different from when, we were just seeing widespread, usage of poison ivy and plug X and very basic spear phishing techniques. There's certainly variations across the many different groups that we track in terms of capability, but overall, this up-leveling of capability and skill is, I think, interesting. To go back to the ORBs for a second, maybe, these come in different flavors, and maybe talk a little bit about the provisioned versus non-provisioned ORBs.
Yeah, so we at Mandiant have been doing a deep dive on these for the last few years, and we're really making an effort now to bring to the surface the lessons learned from tracking these networks so that we can propose frameworks and definitions for these networks. We have definitions like words like orb network or proxy network, but I think in the industry we could do a better job of actually discussing what these are and providing frameworks the way that we have MITRE ATT&CK for TTPs, or we have the cyber kill chain to describe intrusion phases. One aspect that we wanted to do is really define these networks down to what different types they come in, and then also, as I'll talk about in a second, kind of establish the different parts of these networks. So really, Mandiant sees there being two primary types of orb networks. There are, like you said, provisioned and non-provisioned. So when we say provisioned, these are going to be orb networks that consist of leased VPS devices. These are not compromised routers or IoT devices like is usually synonymous with these orb networks. There are networks out there that are 100% a orb administrator going out and leasing VPS space or servers from common ISP providers, not illegal bulletproof hosting providers, things like Chupa in California. These are hosting providers that anyone can go out and rent server space on. They're renting these servers and then provisioning them with Linux images that are custom to the botnet that they then basically relay all their traffic through. That is one structure that we see, and we're calling that provision because you go out and you actually buy or provision yourself a server and then install the operating system on it and administer it. The other main type of orb network that we're seeing is a non-provision network, and that is the more synonymous use of an orb network. That consists of compromised routers and compromised IoT devices. Those are going to be augmented by the orb network administrator, meaning they have malware to go out and compromise more routers to introduce them into the orb network the similar way that a botnet or a worm would work to kind of bring these servers in that can then be used to relay traffic through. And one caveat there, it is a common aspect within those non-provisioned networks of compromised devices to also see leased VPSs being used at the higher levels of the network, like in the adversary-controlled operation server or in the relay nodes that they use to authenticate to that orb network, because you can't host your entire infrastructure or your back-end payload files on a compromised router that might go down tomorrow. So non-provisioned networks are usually a collaboration of leased and compromised devices.
And when you're looking at that from the analyst perspective, is there one that's more surreptitious than the other? I guess thinking more of the latter. Is that more difficult to track, to analyze how the makeup of those networks?
I would, that's an interesting question. I would say that there's definitely more room for complexity in the non-provisioned networks because imagine how many different layers of types of devices you can layer on top of each other if you don't have to have a technique as an actor to go out and be like, okay, I lease this type of server from these 18 ISP providers, and I need to scale my process to be able to put an operating system on all of those, and I need to know it's going to work when I want to route my traffic through it. People tend to get lazy because that's how we are as human beings. In the case of non-provisioned routers, you might have malware that compromises Cisco routers, that compromise ASUS routers, that compromise IoT cameras. So you're working with a lot of different devices that might have different signature possibilities on it. So I would say complexity leads to a bit of a more difficult aspect in detection. And usually when people are just replicating the same server again and again, they're going to repeat themselves, which is ideal for detections.
And you touched on this a little bit, but maybe go a little further on the framework that Mandiant kind of designed, because you noted that this is a little bit different than how we traditionally see botnets being employed. So maybe talk a little bit about the universal anatomy that we came up with to talk about this particular problem.
Sure. So I'd like to start simple. So Luke, you have a foot. I have a foot. A kangaroo has a foot, as well as an elephant. The anatomy of those animals and humans are very different, but we understand the function of what a foot does based on the word. It's something that you stand on. The intention of this universal orb anatomy is to define the core sections of orb network anatomy that can be utilized to describe the components of it, regardless of what the network architecture may look like. You might have a network where the nodes go in all different orders, but the fundamental anatomy of those orb nodes can be defined based on the function, the same way that a kangaroo's foot and your foot does something similar despite your anatomy looking different. We designed a 5-stage anatomy for orb networks that define all orb networks. All orb networks can be described with these phrases, and we start at the top and then we're going to work our way down. So the first stage is what we call the Adversary Controlled Operation Server, or the ACOS node, which is an abbreviation. That node is the actor's ISP space. That is their host that is usually going to exist in Chinese ISP space behind the Great Firewall. On that server, which is not just their machine, but also the server that they're using, they're going to house things like their backend scripts. They're going to house the tools that they use to deploy and administer the actual node network. And they're also going to have databases of all of active ORB nodes within the network. They need a space to operate from, and that's our Adversary Controlled Operations Center. Adversary Controlled Operations Server. You can think of it like the command center of the ORB network. That's where they administer everything from. Underneath that is what we call the relay node. That is the node that the operators, as well as the users of the ORB network, so different APT actors that pay for the right to use this network through some sort of contract, whether it's military or government or something else, that is where they're going to access your ORB network from. So when you access your VPN, you have to hit a server to authenticate to your VPN server, and then you're authenticated, and then you can browse the internet surreptitiously. That's the same story with these ORB networks. So the actor is going to hit these relay nodes to get relayed into their network, as well as the actors are going to authenticate to the relay node. And at that point, they start traversing through the ORB network to all the compromised nodes or provisioned VPS servers that might be there. So the third universal ORB anatomy aspect is the traversal nodes. This is what we think of when we think of ORB networks. This is the botnet. This is the majority of nodes that we're going to traverse through. There could be multiple layers, there could be multiple types of nodes, or they could be all the same type of node depending on the network, but we're going to navigate through this large pool of traversal nodes until we hit an exit node. So similar to a Tor exit node that we're familiar with, this is going to be the node that the actors are egressing from to target a particular environment. So when you're exiting your ORB network, this is the last hop before you're about to enter your target destination or your victim environment. And that node, it could look identical to a specific traversal node. It's not guaranteed to have its own specific profile the way that those other stages are. It's possible that it might be something that looks exactly like those traversal nodes. And then finally, the last one is something as simple as a foot. It's the victim server. That's where you're ending up and targeting after you exit all of your traffic through the ORB network. One thing I do want to mention, Luke, is it's really notable that at the higher end of our ORB network anatomy, in the ACOS layer, as well as in the relay nodes, those are nodes that are usually going to exist in Chinese ISP space or in Hong Kong friendly ISP space. And largely, that is, I believe, to be an effort to prevent the disclosure of any information on those servers and making it more of an opaque environment to host the sensitive user or customer facing, APT facing nodes within a network. It's harder to discover information about those and therefore safer in the Chinese ISP space.
And I think it's useful to have this framework, as you mentioned. These come in different flavors, and they look different in terms of the makeup of the components. But having a sort of universal framework, same way that we have the MITRE ATT&CK framework, or we have attack life cycles, or the MITRE kill chain. Those are all useful ways to describe aspects of, in those cases, adversary behavior in an intrusion operation that largely are the same. They follow the same steps. So this sort of framework is something that you can apply regardless of the actual makeup of the ORB to different ORBs, to future ORBs that we come across, and give kind of a universal way of us to understand and communicate about the different aspects of this activity.
Yeah, it is for enterprise defenders by enterprise defenders. And hopefully this makes it easier for us to kind of standardize how we're trading intelligence on it and shift from a adversary-centric approach to tracking to include also a infrastructure-centric approach to tracking. I think for a long time, we've thought of network IOCs as a guaranteed one-to-one attribution point for these for any sort of intrusion. The complexity of these ORB networks is really that we now need to better define these terms so that we're not just calling these botnets or network IOCs. These are independent administrative entities like an APT or a fin crime group that have specific TTPs that we can look at holistically to identify these nodes and proactively shift to keeping up with ORB, not just adversary, but ORB TTPs, and get ahead of that activity, get that intelligence out so people can defend their enterprise environments.
So we're putting out this episode in tandem with a blog that goes much further into this, and I recommend folks check that out because there's a lot more in terms of graphics, things that I think do a good job of explaining some of the complexities of this. But maybe just as an example, one of the ones you reference in this blog is SPACEHOP. Maybe just kind of the high level wave tops of what SPACEHOP is, how it operates, as an example of what we've been talking about here.
Yeah, absolutely. That's a great example. That's kind of our poster boy orb when it comes to orb networks. So SpaceHop is pretty much a direct mirror of our universal orb network anatomy. It is a provision network. So remember, that's going to mean they go out and they lease their VPS servers from ISPs all over the world. And they have an interesting practice where they actually create panels on infrastructure that they also lease as their relay nodes so that users can authenticate to the network through panels hosted on adversary leased servers. So those servers are going to be leased in cloud organization ISP space within China and Hong Kong. So consistent with what we've seen in the past. And we're also going to see the majority of their nodes be distributed globally. So it's really important with orb networks to note that there's a big motivation to have a diversity of orb nodes that exist around the world. If you've ever had a VPN and ever had to try and simulate a malware environment to get a response from a callback server, you know the VPN that has nodes in Asia or in Europe or in Africa or the Middle East or Latin America is more desirable for the user. If you're an APT actor that is trying to target a multiplicity of users around the world, the adversary is going to want nodes in a lot of different places. So they, interestingly, go to providers in France. They go to providers in the United States. They go to providers in India and Asia, and they lease their servers, but they provision the same operating system, Linux FreeBSD, to those router devices. And then they stand up services and ports on those routers so that they can traverse traffic through those servers that they have leased. And the way that they stand up those ports and servers, as well as the profile of some of their TTPs and registration, gives a pretty decent image of how you can go about identifying those as they get stood up all over the world without a common ISP provider being behind them.
So let's maybe zoom out for a minute and talk a little bit about, we highlighted this in M Trends this year, that we're seeing a greater focus across the board, different types of adversary activity, criminal, some of the APT stuff, where there seems to be a larger focus on evasion of detection. That's certainly always been a hallmark, and similar to the orb stuff and some of the other things we've been talking about. This is not necessarily super new. But I'm curious, your thoughts on kind of how this fits specific to China-nexus cyber espionage groups. And we think about, again, the growth and capability that we've seen over the years from these specific types of groups. What is it? How is it notable, or how does it kind of play into our larger understanding of the dynamics of how these groups are operating now?
So orb networks being deployed at scale by cyber espionage actors, this isn't a phenomenon. This is really a standard practice that has been adopted by a large number of Chinese nexus APT actors. We're no longer talking about a custom botnet being utilized by actors like APT31 that has been talked about previously in like the backdoor malware. We're talking about, since 2016, the rise of a private sector industry that has really been created to facilitate evasion at scale for China-nexus APT actors. So in previous iterations, you were able to focus on one adversary in China and defend your enterprise against just a single APT actor that's targeted you before, or targeted you as a defense sector entity or your partner organization. Now, these orb networks are being utilized by a multiplicity of APT adversaries. It's not just one APT knocking on the door. This infrastructure is being used with exit nodes being recycled within 2-week periods by multiple APT actors. So defense evasion is now something that has basically been, I'm going to use the word offshored, but it still exists on the same shore within China, but has been outsourced to another third-party contractor. So think of if the weaponization phase of the cyber kill chain now has been basically contracted to a private industry entity. Their only goal is to augment and improve the quality of that orb network you're using. So many APT adversaries all of a sudden got very good at using orb networks. And there are orb networks popping up in association with a lot of different APTs. The complexity of this is an APT doesn't have to use the same vendor forever. You might see an APT actor navigate from one orb network to another network. And you might say, this activity looks exactly like temp hex or APT 40, but that's not the orb network they use. I think we need to get into the habit of asking ourselves, does IP and network IOCs equal attribution? Because multiple actors are using these orb networks simultaneously and actors can navigate between different orb networks depending on which vendors they have, we need to ask ourselves a better question, which is which APTs are using which orb networks and what TTPs in those orb networks can we track to kind of start shooting fish in a barrel. If you're able to identify an orb network, you can identify infrastructure for multiple APTs versus we are only identifying TTPs of one adversary that might be hopping around between networks. So it's a little bit of a mind shift, but yeah, defense evasion at scale is now basically purchasable in the orb market within China.
Talk a little bit more about the attribution problem posed by this, because I think that's, attribution is obviously, a persistent issue regardless of what problems that you're looking at in cyber. I think with respect to some of the China-nexus activity, we've seen this evolution over the years where there's been the reorganizations. You've had, groups previously appear to be connected to, say suspected PLA affiliated groups, and then shift maybe that malware is now being utilized in what appears to be more of like an MSS mission set. And you see things where, there's maybe shared builders that are being utilized by multiple groups, but those groups' operations tactically look very different. The targets look very different. What are some of the attribution challenges? And I think you've touched on this a little bit already, but some of the attribution challenges specific to the orb piece, and you maybe even also dealing with like the ephemerality of the infrastructure.
Absolutely. So inherently, I think intelligence is a target-centric practice. So to make that simpler, we need to do intelligence on something, which has always been in the past adversaries, APT actors, one APT actor. So I think as the private industry and the government has introduced a lot of reporting and really built a field and scientific practice for collecting on these actors, I think our adversaries might have been studying that practice simultaneously. And as those multiple reorganizations occurred, have really leaned into certain systems that frustrate and complicate our ability to attribute in a target-centric way to a single APT. That's really what these orb networks are able to accomplish. They take previous infrastructure, which would have been registered by a threat actor with an email address or a fake email address and certificate data that would have been provisioned by the threat actors themselves. And it has kind of abstracted that one layer into these orb networks that have multiple actors that now authenticate to their space. And you're not able to pick out single pieces of infrastructure as being attributable to one APT actor any longer. You're now in a space where you can say, on this date to this date, I believe this APT actor was using this infrastructure that is part of that orb network because I understand the TTPs of the orb network and I understand the TTPs of the threat actor. So really, for enterprise defense, there is now another column of collection that is a non-target collection that we're kind of responsible for. And on the issue of ephemerality, like you mentioned, these orb networks, it's their job to keep these networks updated, current, and one of the main selling points that they have to offer is the freshness of infrastructure. Many of these networks cycle out compromised devices within 60 to 90 days. So we're no longer looking at a domain being hosted on an IP over 6 months that they have one campaign with. We're now looking at a professionalized service of multiple private entities within China that their job is to cycle out infrastructure, compromise new routers, create new leased VPSs to route their infrastructure through globally, to maintain the diversity of nodes, to enable all of their customers to host cyber espionage activities through their networks. So this collaboration between public and private industry has really facilitated an acceleration of the usefulness of network IOCs. Like they're no longer, their shelf life is decreasing. They're no longer you can just block them in your SIM and just let it sit for a year and then age them out. Realistically, as network enterprise defenders, we now have to ask, when was this IP part of this network, and is it still part of this network? Am I still defended against this individual orb network? Which is a lot of work, man. I'm not going to lie.
So, I mean, I think this is all very interesting if you are interested in China-nexus APT activity, if you're interested in cyber espionage more generally. If you're listening to this and you are someone who works, let's say at an aerospace company or an energy utility, and you're like, okay, as a defender, what do I do about this? How do I approach hunting for this, detecting for this activity? What are the things they should be thinking about looking for, or the mindset they should approach this problem with?
Absolutely. So, even in small scale enterprises, just being aware that malicious activity might originate from a compromised home router or an IoT camera. I worked at a SOC early in my career, and there are some things that just automatically got thrown out as noise in the internet. So, if it was residential ISP space communicating with your enterprise, you're going to assume that, oh, that's just normative noise on the internet. Changing that paradigm to ask yourself, could that possibly be one of those orb networks where we're seeing activity that is egressing from that network to touch our perimeter? Is that something that we should be concerned about? So just starting by asking the question, hey, everybody in the SOC, let's take one step further to investigate residential or small business routers that are associated with residential ISP space. That's the first. And then I would say, if you're seeing traffic originate from random numbered high ports, so port 38,610, that's kind of an unusual port. By practice, there are a lot of these orb networks that are beginning to utilize randomized high number ports to try to evade commercial common scanners that are going to scan up to 10,000 or 12,000 standard standard port ranges on servers. So by elevating those port numbers, it's an attempt to evade particular detection for these orb networks. So residential ISP, residential device communicating on a super random high number port, just pause for a second and ask, could that possibly be an orb network?
So tying this all together, I mean, you talk about the fact that there is some ephemerality built into this problem set, but we also have this framework that seeks to kind of capture all different aspects of this, how this is being applied, how this is being used, that should have longevity going forward in the future as we track this problem as it continues to manifest and we find new orbs. What are you looking for? What are you expecting we might see, with respect to how this activity evolves?
I am hoping, this is what I am hoping for, that the industry, and myself included in that, we continue to dig on this issue and we introduce a level of familiarity with these particular entities that allow us to trade in the currency of Orb 1, Orb 2, and Orb 3, which are our first three Orb actors that we've delivered. I hope that in that framework, we're able to meet the growing privatization of internet infrastructure used by China-nexus actors. We're going to continue to see botnets that are compromised and used to route traffic through. This is something that exists mainly in China-nexus actors, but we're seeing touches of it in Russian actors as well, and for a long time in the cybercrime space. I hope eventually, as China actors continue to expand on doing this, which they will, they're going to continue to adopt this. It's going to get cheaper to use, easier to use, and we're going to see the wider prevalence of orb networks. They've been around since at least 2016. It's 2024. They are becoming mature. I hope that our familiarity with those orb networks, makes us more able to defend against them just by raising awareness around them. But I can almost guarantee we're going to see more and more China-nexus actors using this non-attributable ISP space provided by orb networks within China.
Yeah, it strikes me sometimes we may overuse the term, growing complexity of cyber threat activity, but I think in this particular case with this topic, it's certainly well warranted. So it'll be interesting space to watch how it continues to evolve. Michael, thank you for your time today. This is I think a great explanation of this problem. I would encourage folks to go check out the blog that you wrote, and we'll link to it in the show notes. And thanks for your time today.
Thank you, Luke. It was a blast. Look forward to being back.